So today we're going to start and talk about functions. So the formal definition is very simple. So let's say there is a function f from a set D to a set let's say y. Okay. So it means, let's say if this is the set D, right, and set y is here, that means for some value of x, let's say there will be some value here at y. Okay, so we define this as something like y is equal to, let's say, f of x. Okay, so kind of you can say like it's like a machine. Okay, so there's like a machine, let's say f, you input x, you get y. Okay, so there are two conditions of functions. The first function condition should be nothing should be unmapped here. So there exists for for all x belongs to D, there exists some y belongs to big Y. Okay, so you cannot unmap any of them. This is like the main condition that you have here. Okay, and it can happen that this is not mapped here. Okay, so like that might be the case. Let's say 1 2 is here, let's say 2 4 6 is here. You map this to this, map this to this, and this is unmapped. So this is okay. So this whole set is called the codomain, and this whole set is called the domain. So the selected parts which are mapped are called the range. So these are some terminologies. Okay, so yeah, so this is the basic, like a function can be anything. Like here you can see the function is that f of x is equal to 2x, right? So whatever the value of x will be, you'll have 2x. So you should also know how some, like, so this is the main thing you have to this thing is called the arrow diagram. Okay, so you have to realize that this is the thing. So like functions, now you have to know also some like famous graphs. Okay, so that you can draw that in the exam. Okay, so in some cases, like for example, if I tell you, let's say x and log x, can you relate this? Okay, or let's say not x, so let's say x and x square. So what I can do is that I can draw this graph. So x square graph looks like this, and it will touch here, something like this, and x looks something like this. Okay, so if you notice, after a point, x is much lesser than x square, but there is some area where x square is less than x as well. So you can do some analysis. So you need to know how graphs look. So like you can do and plot it. There's a beautiful site called Desmos where you can easily plot this. Okay, so yeah, so one easy way of, there's a linear graphs. So let me wait, linear graphs. So for example, linear graphs will be something like, let's say y equal to x passes like this. Sorry, can't draw this. So simply, how do you draw linear graphs is very simple. Let's say you'll have linear formulas. So y is so let's say if I give you 2x plus 4y equal to 7. Okay, so how do I plot this? There is two ways to do this. So what you can do is you can arrange y in the form of something like this. You can either do this, or you can do something like x by 1 by y by half. No, sorry. So another thing you have to do, you have to divide by 7 everywhere. So x by 7 by 2 plus y by 7 by 4 is equal to 1. So these are the two ways you can arrange this. If you do the first one, okay, so let's mark this as orange. If you do the first one, the thing is that you have to go to 7 by 4 towards y. Let's say this is 7 by 4, and you have to, this is your slope. Okay, so this value is tan theta. So you have to do theta is equal to tan inverse minus half. So whatever the value is, and then you wait. I am so ass at this drawing. Then you have to plot this. How do I plot this? Yes, you have to plot like this. Let's say, okay. Let's say this crosses here. So here, okay. This is one way to do it. and let's say do this blue. Otherwise you can do what, if you arrange the right side as 1, right, so you can put this value 7 by 2 here, and here 7 by 4, it's already 7 by 4 here, right. So you can just do this and draw the line like this, just join those 2 points and that's your line. So this one is wrong, so we will tell why it was wrong, my bad. So since it's minus, the tan will be in this direction, right, so it will be something in this direction only. So my mistake, this is how you can draw like linear graphs. And now if you go and focus on piecewise, like this is a very important graph called the greatest integer function, let's say this. So the greatest integer function, this means that is the greatest integer less than equal to x. So for example, if I do 3.1, what is the greatest integer less than equal to? That will be 3. Now if I do minus 2.2, so what many people confuse, they will write this as minus 2, but that is wrong. See the number line, so this is minus 2, this is minus 3, minus 2.2 is somewhere here, right? So greatest integer lesser than this, so this will be minus 3 here. So there was this one question that many people had messed up. So my pi plus minus e. So how do we do this? Pi will be 3.14, it will be 3. Minus e is minus 2.71, that will be minus 3. So this becomes 0. So this is a simple sum, but many people make it wrong. So now we can also define something called increasing, decreasing functions. Increasing and decreasing functions, how do you define them? So for all x, not for all x, let's say for any x1 and x2, where x1 is less than x2, implies that f of x1 will be less than f of x2. This is the increasing function. For decreasing function, you can write it as f of x1 greater than f of x2. Now one thing you have to realize, that this is something called strictly increasing. Okay, this is strictly increasing, but if you put an equal to sign, it's not strictly increasing, it's just increasing or decreasing. One will be strictly and one will be not strictly. So, and there are some graphs, for example, which are symmetric as well. So like this is what? This is symmetric along the y-axis. And let's say if I have this is symmetric along the x-axis. And let's say if I have something like this, for example, so this will be symmetric along the origin. Okay, this is almost the curve of x cube, this is a hyperbola, this is a parabola. Okay, so yeah, you can just search the formulas for this and you can draw these. Okay, so linear function is what we have shown you. Now another important thing is the power function. So like if I'll just draw few, this is y equal to x, this is y equal to x square, this is y equal to x cube, this is y equal to x, this will touch, I cannot draw this, 4, and y equal to x to the 5. So basically nothing but the squares will look like this, but this base will get flatter. The odd will look like this, means x to the power a, where a is even or odd, but the base will get flatter for this as well. Okay, so that's it. And yeah, so you can draw like this, like there are many ways you can draw this, not a problem. So the reason this exercise is being done is so that you know how these things actually work. Okay, so now we'll also now do combination of the functions. How do I combine these functions? Okay, so I need to combine these. So for example, I give you a sum, g of x equal to root of 1 minus x, f of x is equal to root x. Okay, so obviously if you're combining that, you have to first check the domain. So this, what is the domain for this? The domain for this will be minus infinity to 1. So for greater values, this will not give a negative result. And for this, it will be minus infinity. Sorry, not minus infinity. 0 to infinity. Okay, I did not tell this. What does this and this means? So if I write 0, 1, this means any number in the range of 0 where it is equal to 0, this is not equal to, okay, this is less than. So if I had put this bracket, it means equal to. If I put this bracket, it means not equal to, just less than. So whenever you are doing this combination, you have to do the intersection of that domain. So what is the intersection of that domain? It is nothing but 0 to 1, because this is the only place this summation will exist. Okay, so that's the thing. So you have to do the thing, and plots are same only. So you have to just plot these two functions, the summation of these two functions, whatever the values are in this. Okay, now we'll also talk about something called composite functions. What is composite function? Let's say fog of x. What does this mean? This means f of g of x. Okay, so basically you have x, you have a g, you get g of x. Now you import that in f. Now you get fog of x. So let's say we have f of x is equal to root x, g of x is equal to root over, now let's do x plus 1. Okay, so if you do fog of x, what will it be? Fog of x will be first g of x is what? X plus 1. Then f over this, so root over x plus 1 will be your answer. Now if you do gof of x, okay, g of x, well, what will it be? It will be root x plus 1. Very simple to understand, right? And how do we now do shifting as well? This is one thing. Let's say we have x square, right? So if I do draw the graph here, now if I do minus 1, okay, so minus 1, you have to shift it downwards. This is the negative one. And if you do plus 1, you have to go above. As simple as that. So whenever we are doing outside the x, it's a x-axis move, y-axis movement. Why? Because this is my function, na? X square plus 1. So we are adding 1 or minus 1 or minus plus 3. So this is getting added to the y, no? So that's why the movement is along the y-axis, not the x-axis. Now if I had done this x, let's say minus 1 squared. So here the scaling would have been in the x-axis direction. Okay, so it will be something like this. It will be moved here by 1. So negatives, again the negative side is here, the positive side is here. How do I do this? It's very logical. So where will y be 0 when x is equal to 1? See, x is equal to 1, I put y equal to 1. So that's why the shift is here. So if you ever forget, you can do this. Okay, so yeah. Now if I do, let's say y equal to minus f of x, so this will be a x-axis reflection. And if I do f of minus x, this will be a y-axis reflection. So I taught you a reflection right now. So let's say if I have something like this. Okay, so if I do f of minus x, so every value will be minus like this. And if I do minus of f of x, that means for every minus value we'll have that. So here it will be something like this, as simple as that. Okay, so yeah, so this is the main logic between that. And you can also do scaling. How does scaling occur? Let me show you once. So let's say I have a graph like this. If this is f of x, let's say if I do 2 of f of x, 2 of f of x means it will get compressed. Sorry, it will get stretched. So this becomes something like this. And if I do half of f of x, this gets compressed to half of the value, something like this. So you have to realize this. These are some tidbits you must remember, otherwise it does not make sense. One thing I'm not going to do, which is very simple, I guess, how sine, cos, tan, cot, sec, cosec work and look like. This is something you can easily search and I don't think this is something that should be taught. It's something to be memorized, not like taught. So you can do that yourself. And yeah, and some extra things I will tell. So like we talked about something like this, right? So the domain was there. This is the range, means codomain. So let's say if every one value here is mapped to one value here, right? So so the first condition, what did I had told? Ki all x belongs to D is mapped, right? The second thing is that one value in D is mapped to only one value in the codomain. So you cannot have a case like this. Let me just erase this. Let's say. So you cannot have a case like this ever in a function. Okay, you cannot do that. So only one value can be mapped to one value only. But you can have the reverse. Okay, so like it can be something like this can happen easily. Okay. So you can see this thing. This thing is called many to one. Many to one, because you are having many to one. So if you did not have many to one, if you would have what? Let's say like this. This will be what? One to one logically, right? And let's say, and this is not mapped properly, right? So there is something that is not mapped. So this is a function. See, all x is mapped, correct? One value in D is mapped to only one value in CD, which is also correct. So this is a one to one. Now let's say if I add this and I map this here, for example. So all the values of this is mapped. So we knew that range is a subset of codomain, but now if range is equal to codomain, we call it a onto function, onto function. And we have another thing to tell. If any function is one to one plus onto, we call that function a bijective function. We call that a bijective function. Okay, got it? And let's talk about one more thing that is called periodicity as well. So what is periodicity? Let's say a function that repeats after some time, right? So for example, let's say sine x. So let's draw the graph of sine x, I guess. Wait, let me change the color. Okay, this is not a good drawing, but please adjust. So you see after this is 2 pi, right? And this is 4 pi. So at every 2 n pi it repeats. So sin x has a periodicity of 2 pi. So after a 2 pi it repeats. So this value is called periodicity. So periodicity is like f of x plus t is equal to f of x. So this t is called periodicity. Okay, I think that is more than enough to know how graphs work, and I don't think so. Periodicity is done. I don't think anything else is there. So functions work. So that's it for functions. Like if anything additional is there, it can be learnt from any book. So I am following this book called Thomas Calculus. So whatever is there, I am just doing that. Whatever the topics are. So that's it.